variables are never the same, right? They can't be the same. Okay. What's our next even? We have 2. We have 4. We have
6, 8, 14.
What? Go team. There's 6. There's 8.
That was a stupid joke. I'm sorry.
Oh, I was so excited. 14.
14.
Party poopers. My hand, not my hand. The hand. That little hand up there is on the answer because this is just checking with deriving. Derive and check. Check and derive. Alright. 5, 4, 3, 2, 1. Number 30. No, missed it. Here it is. Who did you guys make you? X squared minus 8x plus 1. I agree. Now question. Who is, now remember, CalcAB doesn't show, well, you guys were only able to check the odds, but odds are like evens. CalcAB doesn't show the nice pretty u sub like I do, but if we do make you this guy, right? Question. Let's just skip a step for sake of me and the little mouse. Who would we make? Don't judge. Du. Now, 2x minus 8. Some of you tried to go ahead and solve for dx, which you should have done. Solve for dx by dividing to the other side. But when you went to plug in, you might have been a little stuck. Because when you went to plug in, you would have changed the dx to be du over 2x minus 8, and you're like, stink. However, some of you saw, wait a minute, what can I do with this? I can pull out a 2, and as soon as I pull out a 2, I have x minus 4, right? And then what happens to the top and the bottom? Nice, right? And that's just square root of u, and the little 1/2 comes out. So 1/2 I have, now guys, remember they're doing their weird, like, writing it with x's thing, blah, blah, blah. You write it with u's and du's. You end up with 1/2 the square root of u to the negative half du. Easy cheesy, we got that. Final answer should end up to be, oh, the 1/2 and 1/2 cancel. Just kidding. Square root of x squared minus 8x plus 1. Let's see. Number next one.
62.
62. Oops, sorry. 2 times 8 minus x squared to the 3/2 over 3 plus 5/3. Wait, how did they know C? Because they had a clue. Exactly. Now this one, some of you guys got stuck on directions, but they gave you a derivative and they said go find the original, which means you have to anti-derive, right? U should have been the inside. du matches up with him, kind of. And you got to plug in, once you have your expression, you got to plug in y is 7 when x is 2. So they plugged in 2, set it equal to 7, and then solve, solve, solve. Final answer, 8 minus x squared to the 3/2 over 3. Sorry, times 2 plus 5/3. Remember the next one?
66.
66. You guys have the final answer? Remember, get the answer first, and then if you have time, go get the work. Final answer on 66. Negative 2/5. 2 minus x to the 3/2 times x plus 3 plus c. Remember, this is the AP guy version, right? Do you guys see the original version that some of you might have gotten and then stuck it to the man? Well, hopefully you guys started plugging in stuff. But do you see how they said, hey, there's a 2 in common, there's a u to the something in common, and then they even made a common denominator and pulled out a 1/5? This was just like the class one that we did. Not the hard one, but the easier second example. Any more? Yeah, and what was the other one? 90, the first one? Oh, so 103 was first, then 118? Okay. Let's peek at 103 real quick. He was kind of a hard one. The clues they gave you were rough. Hold on, focus. When they give you dv dt, and they said inversely proportional to the square of. Inversely proportional is something you've been learning since Algebra 1. It comes up every now and then. It's k over who they're talking about. So inversely proportional k over the person squared is what they said, the expression squared, so t plus 1 squared. You need to go back to V. We gotta move the dt and then integrate. Integral of that guy is that guy. Then they did a u sub with t plus 1. The k is just a constant, so we can theoretically pull him out and he just stays in the answer. He's just a number, like as though it's 2 or 3 or 5. He stays. They integrated u to the negative 2 du. After doing u sub, they ended up getting this guy as the expression. But then they gave you 2 clues. The value is 500,000 at 0. The value is 400,000 at 1. You got to plug in your 2 clues, and then don't we have a system of equations? 2 equations, 2 unknowns, right? So we could use substitution, solve for C, plug in for C, and solve for K. We could use elimination and subtract down, because the C's will cancel. Either way, long story short, solving the system with just algebra, we end up with those 2 numbers, which means we end up with the entire equation with everybody plugged in. At which point we can say, what's the value after 4 years? Boom, I got that. Plug it in, done. Final answer, 340,000. I did have a few questions on that after school, hence why I took time to go ahead and look at it. Number 118 is the last even. Last even. Here he comes. Final answer is A. Final answer is A. U should have been the 1 plus 2, 10. U should have been the 1 plus 2, 10. An average value, you plug and chug, answer is A. Alright, so there are no more evens, right? Cool. You guys, I want you to go ahead and open up your homework spiral. Turn it backwards, like turn it so I can see the first page of your 4 or 5 homework. And keep it out. I'm going to have you guys start doing some examples, and when I call up your group number, everybody comes back and shows me real fast what progress they made. All right, cool kids, here we go. Yesterday, did we get to finish this example? Nope. So let's be amazing. Just needs long division. A lot of you guys should have practiced it last night. Go find me what this division gets, put it back in the integral, and solve. And as you guys start on that, group number 1, come on back. Caroline, Haley, and Jason. Today is February what? 9. Oh, that's Haley, we're claiming absences, right? Catching up. So I'll mark it as missing, but you have the chance to make it up. Okay. Yeah. Yeah, she did. Group number 2, come on back. Or hand on back. I just need to see who you are and what work you have. Good, Brandon. Bridget, this is you? Way to go, team. Aaron, this is you. Alright, keep it going, but I'll count it because you got some good work done. Group number 3, walk it on back. Group number 4, walk it on back. Number 5, let me see. Who has stuff for me?
Sorry.
Yeah. You'll know how to do him today. So if you want, you can keep him out just a minute. in just a second. But first of all, you guys should have this puppy done. We're good? Alright, did you guys put in x squared? Come on. Don't kill any seals. It'll mess everybody up. What do I mean by that? Division means you subtract, right? And when you subtract, to save the animals, you distribute. Ooh, what happens? Everybody's gone. Bring down the 0x, bring down the 5, but wait, 0x is just 0. Oh, so I'm done. Okay, what do I do with 5? 5 is my remainder, right? Because x doesn't go in. Exactly. So I need to go ahead and rewrite my integral and say, okay, this is the same thing as, we have the remainder, we have x squared. This is the same thing as x squared plus 5 over x minus 3. Did that division make this integral so much easier?
Yes.
Yeah, right? Because now we can say, oh, no big dealio, we just got to solve this guy and this guy. The first part's easy. Do you guys know what I'm doing when I say, hey, this is 1/3 x cubed plus 5 times the integral of 1 over x minus 3 dx? What am I doing? I'm using the power rule for the first one. I'm using the sum and difference rule to say I can take them piece by piece. The integral of the first one's easy. Let's do it. Plus, I have to still rewrite the integral of the second one because what kind of integration do I have to do? U sub du, this one's a nice one, just equals dx. You guys notice whenever that happens, you just get to go ahead and plug in dx is du. Put in the u, and if there's nobody else chilling, man, we're almost to our answer. How we doing? Good, good, good. That long division makes a difference, yeah? Yeah, 4.6, there's a lot of division to begin with. But I had people working on it yesterday after class, and they were like, hey, it's not too bad. So we're doing a lot of examples like it. 1 over u goes back to ln. I went ahead and just said ln of u, whatever, plug it in. Remember, we have the u right here. Could I put the 5th power up? But he's an odd power. Do the absolute values go away? No. So maybe I'll just leave them down. And we are done. Nice. Fine.
So if you have an even coefficient in front, you pop that up, you can get rid of the absolute values,
Exactly.
right? Got it.
Even power or an even root, which is technically even. Okay. So, why do I have this page here if we already have these rules on a forever card? Are we going to make another forever card? No. No, no, no. But did some of you get to problems kind of like this or this and get a little stuck in section 4.5 and or 4.6? Okay. So we need some practice on these rules. You don't have to write the rules again unless you're like, yeah, I totally don't remember those. Maybe I'll write them down so I have them in my notes when I do my own notes. But the integral of e to the u du is just e to the u plus c. Remember? Like a phoenix rising from its own ashes. Who has not been amazed to discover. How do you find e? 2.71828. What was e to the I pi is 0? That doesn't have to be. I don't remember how you find it. I should remember.
Which part?
It's from ln, or you can say that ln is from e. Struggle. I don't remember that one off the top of my head.
Yeah.
The one you should look at is phi. That one's fun. Phi?
I still like 0 factorial.
Phi is the fun one.
Yeah, I still like 0 factorial as one because not making a decision.
Because phi is where the Fibonacci sequence comes from. What? Anyway. Fibonacci, that's the golden spiral.
Okay, I heard that one of those smart Greek guys, I think it was Pythagoras maybe, thought that like beings were like reincarnation of human souls. So these murderers are chasing him, and he had to run through a bean field, and he refused to do it, so he got murdered. I don't know if it's Pythagoras, it was one of those nerdy Greek guys.
Very interesting.
So, Google it.
Wait! Let's come back.
That's right, it's back in the day.
I'm not going to solve this entire one as I finish checking your guys' homeworks, but I am going to start you off. Actually, no, you're going to start us off. Who is you? U is 3 minus x. You guys should know what to do in the sense of finding du, then you're going to take that puppy, and then you're going to find dx, right? And then, since it's a definite integral, what else are we going to do? Solve for u of 4 and u of 3, true? Then we're going to plug it in. You guys go as I check group number 6. Keep going. Group number 7, let me see him. Sam, Keith, and Ryan, anyone? Remember, if you don't have it today, you can always get partial credit and show me tomorrow. But you have to come find me, Gabby. I'm just encouraging you to keep going.
That was really cool.
There's Keith. So far, I've given everyone hundreds. All I wanted to see was good progress, and I've seen good progress. Just some of you need to finish. That's all right. Okay, group number 8. Huh? Okay.
So, at what
Okay.
point?
Oh, this now.
At what point can you switch the balance to the u?
1 minus 1 over e.
As soon as you start rewriting. Like as soon as you put in the du, get those u bounds in because they'll keep you.
Got it.
But Charlie and Trent, you heard me say the whole like partial credit.
1 over 0 minus e.
Yeah, think like x plus x. You just go back to who is u, plug in x.
1 over e.
Because you have a plus c for the of 4. And you have a plus c of 3.
Over e.
No.
Yeah.
Alright, I already hear some good collaboration. The rest of you guys checking your groups real fast, but here I come. Not Miss America.
Let's leave this.
I borrowed from
1.
Alright, here we go. Hopefully you guys found u. Well, you already know u. Du to be who? So dx is equal to? U of 4 was -1, u of 3 was 0, right? Then he went ahead and said, time to rewrite. And the rewrite would be, remember, top goes with top, right? So I need -1 to go to the top just because that's his placement. And I need 0 to go on the bottom because that's the current placement. So I have -1, 0, e to the u times -du. What can I do with the negative? If you would like, I didn't show this the other day, but I can do it now. If the bounds are switched and you don't like them, wouldn't you flip them? But when you flip them, what happens to the sign? But do you have to do that? No, you don't have to do that. I'm just showing you that you can do that because some of you recognize the properties. Then we can say the integral of e to the u is e to the definite integral from -1 to 0. Or you could go from 0 to -1 and make it all negative.
You don't have to plug in 3 minus x. You have to.
Good catch. Oh. We're not going to x's because who did we make? Oh, common mistake. Even I just did it, and Ryan Murphy, and maybe some others. And then we have e to the negative 1. Anything to the 0 is?
4.
And 1 minus e to the negative 1, isn't that 1 over e? If we want to be super snazzy, why is this the exact same thing? And it's much more AP, by the way.
Multiply by 1 created.
Get a common denominator. Bridget, go ahead.
I got lost after the part we have the negative on the circle. So the next step.
This one?
Yeah, why did the negative 1 go to the bottom?
Because some people see, like, you're used to having the lower number be here and the higher number be there, but based on what we found, it was switched, it was the other way. So some people are like, ew, I don't like it. So then they go ahead and they switch those to become negative 1 on bottom, 0 on top. But when we switch the bounds, we have to think of that property where the integral from a to b of f of x, no. The integral from b to a, if the numbers are switched and we don't like them, we can make them the other way, but we just need a negative in front.
Do we have to do it like that?
No. So I was showing that you could use this property, where you could switch the bounds and then make the negative into a positive. That's what I did. But it would have worked out just as well if you had gone ahead and said, no, I'd rather do this instead. You would have still gotten the right answer, because you would have gotten negative e to the u, 0 to negative 1, which would have gotten you negative e to the negative 1 minus a negative would be a plus, e to the 0, and if you notice, that's the exact same thing as what we have down here. Thank you. Welcome. Kiddos, we could go ahead and do this one and have some fun with it, but I don't really feel like it. But my question to you is, because we have other more important things to do, my question to you is, who is you? I know it's weird, but just make them the whole thing. Because when you go to define du, e to the x's derivative is e to the x. What would e to the negative x's derivative be?
Negative.
E to the u times u prime. Times negative 1. Doesn't that look awfully familiar to something else we have going on?
Yeah, the top.
The top, except those 2's don't belong. That's okay, we can factor them out, right? Then when you plug in, they're going to cancel and dot. Okay. This is more fun. How many of you guys have gotten stuck on a problem like this at least once? Yeah, right? Ugh. Unless you realize, oh, we have a B. Or an A. You can say an A or a B. I say B for base. But sometimes there's an A in the rule. But either way, if we just remember there's a rule for that, maybe we won't be as scared. The integral of e to the u is e to the u. The integral of b to the u is b to the u, but it's not an e, so we have to offset. The derivative says times ln b, so I need to go ahead and do 1 over ln b to get rid of that constant when we provide. That's the rule. I don't like it there. That's the rule. So question, do I mind the 5? Should I mind the 5? Nah, he's no problem, he's a B. He's my base. But what do I need to be a little worried about? Got it, U. Who's du? Negative 1 dx, so who's dx? Aren't I ready for my basic school? So all I need to say is negative 1 over ln of 5, check it, times 5 to the u. This is not definite, right? I'm not plugging in bounds, so I can go ahead and, even though I'm writing 5 to the u right now, I need to keep going and plug in 5 to the negative x. Dun, 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 dun. Got it. I'm going to take questions on that one in just a moment, but as I get ready to do so, if you guys are like, hey, I think I got it, then try the next one. Then try the next one. Questions on the 5 to the negative x one? Do we need to be studying our forevers? No. Wait, 4-6 is done today. We're starting, just peeking at 4-7, finishing 4-7 tomorrow. Worksheet Monday, worksheet Tuesday, review Wednesday, test Thursday. Do you think a forever quiz is coming?
Yes.
Try to get them updated by this weekend. You guys should be studying your forever cards. If you study them now, it makes homework faster because you don't need to go back and be like, ugh, there's a formula, I don't know who he is. Anyway. So no questions on integral 5 to the negative x? Alright, cool. So who's you? Exactly. If u is sine of x, who's du? Well, that's nice. And some of you are starting to maybe make your own shortcuts. Just make sure that you are following each of the steps. I shouldn't say shortcuts. I should say doing more and more mental math with this. When we go to plug in, we say, okay, 2 to the what? Times cosine of x times du over cosine of x. Booyah! Who reduces? So I'm now back to my b to the u rule. Don't be scared of him. We can solve. We just need to remember the rule, which says my antiderivative is who? Keep going. And then we say this is not a definite integral, so we go one more step. That's not an n. Sorry, that was a u. My one more step is? Dun, 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 dun. Yeah, right? You just gotta know the rule.
If we see that du is equal to cosine x dx, can
You
you
can
use
just plug
straight
in.
substitution? We don't have to show that extra step.
You can just plug in. So I'm just going to put it as you get more and more competent with these integrals, you might be doing more and more mental math.
Okay.
Just make sure you're doing legal mental math. And my huge warning is, even if you're like, the u sub doesn't matter, still do the u sub. Because if you get out of practice of always doing u sub, you won't use it when it counts.
Is it going to be like, are there going to be like FRQs if you sub all the multiple choice?
Well, there are going to be FRQs to solve the differential equation, the whole dy dx equals, and you have to show your steps, and they will check your integration. So that's one place where it's going to be super important to show it. But what I'm talking about is, if you see something like 1 over x plus 3, and you realize u sub gets me a du, that's dx, it's really just 1 over u, you might start jumping to ln of and just not be doing the u sub, like thinking it through. And so then when something comes like 1 over 3 minus x, if you don't do the u sub, you'll miss the negative for the du, and then you're going to get messed up.
Okay.
So that's why I just want Angela. Alright guys, we're done practicing. It's really just review. I knew some of you guys were getting stuck on these because they were showing up since you guys know the math bills, especially calculus. 4-7. We've already talked about differential equations, right guys? Move the dx, integrate both sides, and what do you do with a clue? Plug it in. 4C, that's a horrible comparison. Let's just get rid of him. And then the next one. Ooh, that's super interesting. We'll get back to him another day. Let's start again. Ain't nobody got time for the other one. We have to do the warm up tomorrow. 4.7, integration rules. Inverse trig. As you guys are writing, I want you to look at the intro examples. Let me zoom in. And I want you guys to identify which of those could have shown up in 4-6 homework? Not 2. 2 is impossible to solve yet. 1 is possible to solve with just plain old basic U sub. Basic, okay. When I say basic, I mean there's more complicated stuff coming. Not in a scary way, just in a, like, we've done foundational U sub. Huh. Why is number 1 foundational U sub and number 2 says, uh-oh, we need to learn more? What's the difference in the two? Someone raise a hand. Who can clearly, loudly say what you see is the difference? Corey.
Number 1 has an X in the numerator, and number 2 has a 1.
Okay, so there's a difference as to what's in the numerator. And Brandon, why does that matter?
I don't know.
Hmm?
I don't know.
You don't know. Corey, why does it matter?
When you find du, the X's will cancel out, but when you find du for number 2, the X's will still be there.
The rest of you guys raising hands. Is that what you were thinking?
Yeah.
Nice. If we tried the same procedure on both, over here, things will go much more smoothly. Now, you guys have also seen that smoothly doesn't always mean, well, we like smoothly, but just because it's not smooth doesn't mean it's not possible. But I'm telling you right now, number 2 is not possible. Number 2 is the reason that we need section 4.7. Is one of the reasons. So just because it's complicated doesn't mean you always need a new rule. However, I'm just giving you a heads up. Based on my experience and my knowledge, number 2 needs a new rule. So just hang in there. Du equals, we know what to do, dx equals, you guys are still going, right? Du over negative 8x. What Corey was saying and Alan and Ryan were thinking, and maybe others of you. This u has a du with an x that I need, which will work with that one that I have. So when I go to plug in, I'm going to have x over square root of u times du over negative 8x. Now guys, you don't need me to solve this whole thing. I'm just asking, should we be able to get to the end of 1/8, not 8, negative 1/8, not 8? Should we be able to keep going on this one? Oh yeah. Oh yeah. Oh yeah. But here's the struggle with number 2. If we try, and it looks so similar, right? It even looks like some of the ones you guys might have seen last night in homework, or you will see in section 4.6. The difference is that it has a little squared in here. The ones you saw probably didn't have the squared, if there was just a number on top. When we go to do du here, don't we get an x again? When we try to find dx, how's this looking? When we go to plug in, now some of you would be amazing and would say, nah, this isn't going to scare me away. I know what to do if I have extra x's. Go solve for x. Okay. Solving for x, u minus 1 divided by negative 9 will end up being 1 minus u divided by 9 square rooted. Let's just ignore the plus or minus square root for now and say that's not a big deal. Let's just ignore that for now. And let's say we plug that puppy in. So we would end up with the integral of, we can pull the negative 1/18 out. We have 1 over square root of u times the square root of 1 minus u all over 9 du. Some of you are like, well, that didn't make anything better. Well, let's see. Where would that get us? Well, now we could technically make the square root of 9 3 and pull an over 3 out in the denominator. Ugh. That would be 3 over the square root of, since these are both square roots, we can actually kind of put them together. And we would get u minus u squared. We distribute that guy in. Question, is this looking much better than what we started with?
No.
I don't think so. So here's the dealio. What we circled was not you. What we circled was not you. It's what you thought was you. Let me show you something crazy. You ready? Hold on. It's in a whole new section. Just follow. Why?
That looks like
Why did I do that? This is crazy. It makes no sense unless you go back to a derivative rule and you remember all integral rules come from derivative rules. And back in the day, we learned a derivative rule for sine inverse of u. So this is really just
this is getting exciting.
Yeah, that's a lot more complicated.
wait a minute, hold on. Isn't this a derivative rule that we haven't had an integral rule for yet? Is our inverse trig in our basic? Wait, guys, look! We haven't even talked about him. Guess what we're gonna make? Forever number 44. We're gonna practice tomorrow. Wait! Before anyone leaves, what are you supposed to have fully attempted tomorrow? And I might take you a sample on it. Over number 31. Bye, guys.
This is getting exciting.
I don't care.
Do the math.
And then here you are.
Where's that?
Still on you.
Bye, guys.
On you. To go to bed.